presentations from the previous presenters. Mine is probably more of an assembly of practical tips and lessons learned on quite a significant aids navigation maintenance program that I was involved in Papua New Guinea. So my presentation is going to be fairly short. I'm going to go through a few things: the total cost of ownership, effective service life, choice of equipment and structures, maintenance, and calculating total cost of ownership. So total cost of ownership is basically, it's the full cost of an asset over its useful life. This includes all phases, right from procurement and installation, the operation and the maintenance of the AtoN, right down to the decommissioning and the costs that are associated with safely and cleanly removing a structure from service. And every phase is quite critical, and every phase contributes to the total cost, and you really have to focus on each different phase in a different way. Probably the biggest variable on the total cost of ownership is the effective service life of the AtoN. This is certainly something we've focused on. An effective service life of an AtoN is basically the period of time that it can be reliably used to achieve the required availability. So it's the time that AtoN can operate to the service level that you need, depending on its category, and to meet its required availability. So achieving a long lifespan of an AtoN structure is how you get a long effective service life, and that's achieved by a couple of different things. Number one is the design and use of the right materials. Is planned maintenance. So probably one of the most important phases of effective service life is the initial design and materials. So this is really critical when you're looking at AtoN, especially in some of the very remote and aggressive marine environments that we're installing them in. There's a lot of different things to consider here. So depending where you're going to put the AtoN, you really need to identify the most suitable structure and the most suitable equipment for the site. There is no one fit all, and you've really got to look at environmental conditions. You've got to look at how remote the site is. There's several different things you've got to look carefully at when you're deciding on the right type of structure. And you need to keep it simple. There's a lot of cost in installing AtoN structures. The simpler you keep it, the less expensive it is up front, and you should really always design for maintenance in mind. So you've got to be careful of the type of materials that you use. Of course, we all know that corrosion is the biggest enemy of any AtoN structure, so that you've really got to look carefully at the material types that you're using, especially your steels, your grade of concrete, and sometimes spending a bit more up front in using the right materials for your structure can reduce the total cost of ownership over its effective lifespan. And as always, you should standardise. There's nothing wrong with having 30 of the same structures if it's in the same environment. There's no need to get too fancy. There's no need to design big, expensive and difficult to maintain structures. So then we look at maintenance. Of course, maintenance is critical, as we all know. So I've got maintain, because if you're not maintaining your structure, the lifespan is going to be significantly reduced. Maintenance has to be planned. I think this was mentioned in both the previous presentations. Reactive maintenance is ineffective. So turning up to an AtoN once it's failed or partly collapsed will not fix your issue. You need to be planning, and you need to be getting ahead of that structural deterioration or your equipment failure. The maintenance should be kept in cycles and reduce mobilisations. This was particularly important in our experience because of the logistics and just the widespread geographical locations and just how remote it was. So it's important to plan. If you're going to do a maintenance run and you've got a certain region, it's important to plan it so you go through that whole region in one hit, instead of chartering vessels per day or chartering vessels for a week and then demobilising, then remobilising again. And I think Patrick made that quite clear in his presentation that vessel costs one of the biggest costs of all in maintenance, and in other countries it's road, it's helicopter, and it purely depends on where you are. And again, carefully plan logistics reduce the total cost. So the more accurately you plan, your logistics and your vessel charters, your helicopter charters, the less cost is involved. Another big thing for us was training and diversity of skills. Really, when you've got a whole AtoN network, there's a number of different things you need to consider. You've got boat operators, you've got community liaison officers, you've got painting, you've got a lot of climbing, you've got a lot of diving. So you need to assemble a crew of people that have got that range of skills that allow you to basically handle any maintenance or any issues that you find when you arrive on site. And this was particularly important for us. Remote sites equals safety squared, because safety is so critical when it comes to AtoN, and often doing a little bit of training or a little bit of awareness or having good systems, while it may cost a bit up front, you've always got to ask yourself what the cost is of a serious safety incident when you're in a very remote site when there's very little way to respond to an emergency. So these are a few practical tips on structural maintenance, that just lessons learnt from us. Pick an effective coating system that is easy to use in the field. So if you do have a lot of steel structures, you don't want to be always swapping between different paints. You need to pick a paint system that works, but also that is easy to use in the field, and also is easy to control for the mitigation of environmental impact. Repair, prime and paint. Don't just paint over rust. This is another lesson we learnt, that having a bit of rust on a structure, the easiest way is to slap a bit of paint across the top, but this does not resolve the issue. So you really do need to repair that bit of corrosion. You need to prime it, you need to paint it. Sometimes that can mean the difference between doing it once every couple of years or once every 5 years. Shallow water. If you've got shallow water structures, your biggest risk is around that splash zone, where the steel becomes oxidised. So you should look at protection systems for that splash zone, which can significantly increase the lifespan of a steel structure in water. You can look at Denso, or you can look at anodes or cathodic protection. Use stainless steel wherever possible. You could also consider aluminium, but non-corrosive metals are always good to use in a marine environment, because it just reduces the amount of wear and tear and maintenance. And avoid galvanic corrosion, so you should always use the same steels. The impacts of galvanic corrosion when you combine mild steel and stainless steel or aluminium can deteriorate quite quickly. And standardise your consumables. So for all your paint systems, for your protection systems, for your fasteners, your nuts and bolts, try and standardise it to one particular type. So number one, it's easy to procure, and number two, it's easy to store. So AtoN equipment, standardise equipment and service as much as possible. I think Patrick made a good point on this one in his presentation. You should try and keep your equipment, depending on the ranges that you've got, the different structures, different categories. Try and just use the minimal amount of brands and molds that you can, much easier to store. And plan your replacements. This is quite a simple one, but it's quite effective. So for things like batteries, if you're changing batteries out every 5 years, it's much easier if you've got a register that tracks that, shows you the times you should be replacing them, instead of ad hoc or even worse, guessing when you should be changing batteries out, because quite often that will lead to battery failures. Minimise your stock holdings. If you do the above, you really can keep your stock levels quite low. This might seem quite common sense, but I've seen it a lot in the Pacific, especially with water-based structures. It's easy to pull a bucket of salt water up to clean a structure down. Obviously that leads to corrosion, so you should always use fresh water. Use appropriate bird deterrents, and attention to detail saves return trips to site. And it's important for a maintenance technician to understand that when he is maintaining a piece of equipment, double check everything, make sure your battery cables are tight, make sure bolts are not loose, make sure that you've checked inside the lamp, because quite often just missing one simple detail may lead to a failure, which may lead to a very high cost of returning to the site to fix it. And test and record. So everything you do on site, test it, and make sure that you record everything that you do. So records are key to planning, they're key to planning maintenance, they're key to planning budgeting. You should use documented information, so use controlled reports, use spreadsheets, even use software if you have it. Keep those processes recorded, keep your reports easily accessible. Identify, document, schedule improvements or major repairs. Quite often you'll come across a structure, it might be an older structure where there are issues that are developing. You should get into recording those in the early stages. And if there is a major repair coming up in a couple of years, start to record it, start to plan for it, start to budget it. And record your use of consumables. Again, seems like a simple one, but if you record how much paint, how much Denso, how many bolts you use every year, it's very easy to reorder for the next year so you don't find shortfalls during your maintenance program. Just a little exercise we used to use for calculating total cost. So to work out the total cost for an AtoN structure annualised, this is the formula we use. So the total cost annualised was capital cost plus your maintenance cost times effective life divided by effective life, as an example. So your capital cost for a structure might be $100,000. It might cost $1,000 a year maintenance. So the important thing here to realise is your effective service life, how it impacts that. So if you've got a structure that only works for 5 years and you have to remove it, replace it, then that gives you an annualised cost of $21,000. Over 10 years, it's vastly reduced. So that just is a bit of an example of why it's so important in your effective service life, which is designing and installing the right structure and maintaining. So I'm just going to do a quick exercise for a beacon here. These are similar structures we installed in Papua New Guinea, about 65 of them. So the capital cost of using a mild steel structure might be $35,000, whereas you're looking at an extra $15,000 to use stainless steel. So your annual maintenance cost for mild steel is obviously quite high, because you've got a lot of painting, you've got a lot of checking, you've got a lot of Denso replacement, whereas your annual cost of stainless steel might only be $500. So your effective life of a mild steel structure, if maintained, would be 10 years. And the effective life of stainless steel, which is 20 years, as it's a much more durable, easy to maintain structure, is 3,000. So you can see quite a big difference in the annualised cost, especially when you look at the cost of, say, using mild steel structure and having to replace it after 10 years, you repeat the cycle. And without maintenance, those lifespans are significantly reduced. And my last slide is, we all consider the financial costs, but this does not address the fundamental issue of safety availability. So you might save some money on installing a low-cost structure. You might save some money on not maintaining it. But basically, what is the cost of a serious maritime incident? And I mean, that's why these AtoN are being installed.